For those of you who were with us from the start of the day, we heard from two great economists about all of the intricacies, the challenges and opportunities with time of use rates and their design. Later, we heard about from two nuclear specialists and experts, and also Jack Shriver, about the option of nuclear for Hawaii, and does it work or not? And then so now you're going to hear from two engineers who are going to talk about power generation on Maui, and I can't think of a better trio of combination of topics to get us ready for lunch. So without further ado, I'm Colton Ching. I'm just the interviewer, but I'd like to introduce Michael DeCaprio. Mike, I think this is your first Hawaii Energy Conference. So Mike is Hawaiian Electric's Vice President of Power Supply, which means all of the power generation owned and run by Hawaiian Electric, regardless of island, all 5 islands that we serve, they all are Mike's responsibility. Mike has been with Hawaiian Electric for 21 years, and although it doesn't look like it, he's been in the power generation business for about 30 years. So it comes with a lot of experience in operating, maintaining, permitting, engineering, and constructing power plants of different kinds. So great opportunity for all of us, especially those of us who call Maui home, to hear a little bit about what's happening, and there's a lot. As a spoiler, there's a lot happening with power generation on Maui. So let's just get into the questions. Mike, you ready?
Ready.
Okay. So let's start off with Kahului Power Plant, right by the harbor. So we know, Mike, that there's plans for retirement of Kahului Power Plant, but there's a lot more going on or planned to go on there. So can you tell us more about what your plans are for Kahului?
Yeah, sure. And first I want to say thank you for inviting me to do this. It's to me, it's really important to be able to bridge the future, the renewable transition with where we are today and the changes and the impacts that it has on the existing infrastructure. So the Kahului Power Plant, has been in service, has 4 steam generating units that have came online between 1948 and 1966. So that facility has been serving the Maui customer for over 7 decades. That's over 70 years. That's a really long time, and it's done it well and it's done it reliably. But over the last number of years, we've had a lot of challenges with being able to maintain the permits for the Kahului Power Plant, ranging from NPDES permit issues and to the most recent current issue is the air permit. The air permit requires that the units cease operation by the end of 2028. And the reason for that is it's based on the state's implementation of the regional haze rule, which is a rule under the Clean Air Act that essentially requires the natural parks to restore to natural visibility by, I think it's 2060. And so as part of that plan and that those steps for reasonable progress, the Kahului plant must cease operation by the end of 2028. So when the plant retires, we'll have enough generation on Maui with the other generation, the recent 60 megawatt solar and storage farm that came online, the Waiana battery that's going to come online, the new firm resource that's going to come online. We'll have enough resources on the island from a capacity standpoint, but there's other grid services, other issues that need to be addressed, specifically voltage and voltage control and stabilization, especially on the 23 kV portion of the grid. And that's where the future is for the Kahului Power Plant. So after the units retire, 2 of the generators will become what we refer to as synchronous condensers. So what that essentially is you take that steam generator, you take the generator portion, you cut off the steam turbine, and then you spin it from the grid like a motor. So it's a synchronous motor. And that spinning that generator as a motor with the excitation systems allows us to add reactive power or absorb reactive power from the grid, so we could give or take VARs from the system. So that will allow us to help control voltage which is critical to the future stability of the Maui electric grid. Of course, there's other modifications, lube oil systems, other systems in the plant that have to be modified to make this happen. It's a rather large project. But I wanted to point out that it's not just about voltage control, that the synchronous condensers add other benefits to the system. First, it has the potential to add short circuit current, which is really important to ensure that the protective devices can operate and that faults are detected. And so that really becomes challenged as the grid becomes, as inverter-based generation dominates the grid. Having that short circuit current to detect faults and ensure proper operations of the protective devices is critical to human safety and grid reliability. Second, it also adds inertia being that force of continued operation. So we try to maintain 60 hertz. This rotating mass will help support maintaining that 60 hertz. So in summary, as we convert the Kahului plant to synchronous condensers after they retire, that facility becomes a pragmatic bridge between legacy infrastructure and a clean renewable energy future. And it does this by supporting the reliability, which I mentioned, and indirectly reducing emissions, and in a cost-effective manner, because we get to reuse existing infrastructure at an existing site, at an existing interconnection, which just is a win-win for reliability and customer cost.
Thanks for that, Mike. And maybe as I transition to the next question, maybe you might want to bring up the slide that has an overview of all the generation sources on Maui. So thanks for that discussion and explanation of what you're doing and planning to do for Kahului Power Plant. By far, Kahului is the smaller of Hawaiian Electric's 2 generating stations that are in operation today. The other is Ma'alaia Power Plant. So at that power plant, we have 21 generating units there of different technologies. There's a lot going on in there. But I think we've had some earlier discussions around some challenges that we've been having with 4 specific generators there, all coming from one manufacturer. And although they're not the oldest generators at the station, support from that manufacturer is becoming more and more difficult to get. So can you talk a little bit about that, what you've done since we first kind of started to encounter this challenge, and all the other things that you're doing there at Ma'alaia?
Yeah, thanks, Colton. So as you stated, Ma'alaia is indeed the largest generating facility on the island, and it's really one of the most dense generating facilities that we have in our system. 15 of those 21 units are diesel engines, and the others are 2-on-1. We have 2 2-on-1 combined cycle units at the station. So during the pandemic, we received notification that from the manufacturer for the engines, and these are large engines. They're 4 12.5 megawatt engines. So that's 50 megawatts total. So that's a significant amount of capacity. We received a notification during the pandemic from the manufacturer that these particular engines were produced in low quantity, and that there's very few of them remaining in operation, and that many of their suppliers and sub-suppliers have went out of business during the pandemic, and that they may not be able to support these engines in the future, both with parts as well as the technical expertise that we need when we have these bigger outages. So we aggressively tried to address this situation by, one, ensuring that we had firm capacity in the Stage 3 RFP, as well as our energy storage projects that were awarded in the Stage 2 RFP, as well as really working with the manufacturer to get all the parts that we could get right now. So we put in orders for parts that will take these units should allow these units to continue operating till 2030, maybe a few years beyond that. And that'll help as we build out the system and add the necessary generation that allows them to retire successfully. These Mitsubishi units, or these 4 engines I'm talking about, do also have mandatory retirement dates under the same air permit restrictions that are affecting the Kahului plant. But they're from the early 2030s to the mid to late 2030s, and it's really not going to be the critical reason why the plant's retired. We will run out of parts before we hit those permit expiration dates. So again, we worked with the manufacturer, we have parts, and we're able to maintain them to the 2030s. In addition, as we add more of the renewable resources and other resources to the grid, like the AES Kuhilani facility, that allows us to actually run the engines less. And since their overhauls and maintenance is based on run hours, we could potentially extend those outages, keep those engines in service and available to the customer longer if we run them less.
Thanks, Mike. So we started talking about new generators of different types that we're looking to add into the future. But before we get into that, in the near term, with the anticipated and planned retirements of Kahului, and load that's continuing to grow in a trend, there's a lot of things going on, a lot of maintenance that you're doing. So in the short term, tell us how in power supply you ensure that here on Maui, that on any given day, with all the maintenance you need to do, with all of these challenges we've been facing, how do you ensure that we keep enough generation going? What have you been doing in the short term, the near term, day-to-day basis to make sure that we always have more than enough generation available to serve customers?
Yeah, so as we approached the end of life of the Mitsubishis, and then, of course, prior to that, the Kahului, that represents almost a little over a third of the firm generation on the island. So that's a significant change in the generation portfolio, which means that the remaining units will continue to be critical for some time, the remaining firm generation. But they're critical today, too. So it's not just about tomorrow, as Colton asked in the question, it's about today maintaining day-to-day reliability. So we have some of the most technically competent staff that operates and maintains our engines. We've done a lot of work to do massive combustion turbine inspections and overhauls, engine overhauls. And we kind of look at that maintenance schedule. We try to strategically schedule these outages where there'll be minimal impacts to customers based on time of year, whether we have to consider when we do maintenance in the context of a potential PSPS during fire season. So all those things go into creating this maintenance schedule. But we invest in the units. We've invested in controls upgrades. We've invested in modifications on the combined cycle units to allow low load operations. These things give the units the flexibility that they need to transition in this modern dynamic grid, but also because they're able to do that successfully, it makes them more reliable and less stress on the equipment. So it's a combination of maintenance and investment and capital investment in the units to keep them reliable. Of course, for the long term, the future assets, need to come online. The Waiana battery, the Stage 3 projects, and the firm project need to come online.
Yeah, thanks, Mike. So speaking of those future resources, the next resource that we're planning to add for Maui is a large standalone grid-connected battery using the latest technologies around grid supporting, reliable, utility-scale battery systems. So talk a little bit about the Waiana battery. I know you guys are working hard on it, so give us an update on that.
Yeah, so the Waiana battery is something I am personally very excited about and feel lucky to have the responsibility to bring this a new generating resource or storage resource online. But the project was awarded in the Stage 2 RFP and approved by the Commission last year. So since then, we have entered into contract with both EPC firms as well as the battery manufacturer. And we've gotten, I think, almost all the permits necessary to start construction. we're moving forward with, I mean, engineering is essentially complete, and we're moving forward. It's going to come online the end of 26 or early 2027. Some of the lead times with some of the components have, increased, as I'm sure many of the other developers have experienced with transformers and breakers and whatnot. But that project will be built and constructed and connect to our Waiana substation. And the project's going really well. We're watching the tariff situation and the potential for the tariff impacts on the project, just like I'm sure all the other developers are.
Thanks, Mike. So after Waiana Battery, you talked about stage 3 projects. We've got an upcoming integrated grid plan RFP. But specifically for Maui, we're talking about an additional 310 megawatts on a megawatt basis of renewables, coupled with almost a gigawatt hour of storage added to the system. Part of that includes a 40 megawatt firm generator from an independent power producer. But one of the unique things about that project is that IPP project is going to be sited at a Hawaiian Electric property, the very same property that the Waiana battery is going to be installed or will be installed on prior to that. So tell us about how you work with an IPP. How do you coordinate all of that to share a same piece of property?
Yeah, so the Waiana property, the company, I think, procured that property in the 1990s. And it was zoned originally for a large generating facility at that time that never came to fruition. But as part of that rezoning of that property, there's a lot of conditional use restraints for that property. It's a 60-acre property, and it requires a certain percentage of the land to be used for renewable energy generation. So the two projects that are there are critical. Are directly in support of the conditional use permits for the land. But more specifically to your question, in 2023, we completed construction of a very critical substation on the property that allows further integration of renewables, but also adds necessary reliability to the 69 and 23 kV systems on Maui. So we worked with our renewable acquisitions team to subdivide the land to offer a portion of the land of adequate size for the construction of the 40 megawatt firm facility, while also being able to construct a 40 megawatt battery in different spot on the same, parcel of land. Both these projects will connect to the new substation I mentioned, and both projects will be able to export their full capacity at any time into the system as necessary.
Thanks, Mike. Thanks for that kind of very comprehensive overview of everything that Power Supply's been doing. I know you guys are busy doing a lot of other things too. So any final things you want to say? I know we're running a little long on time, but any final things you want to share with the audience today?
Yeah, one thing I would like to share, I think, we're working towards this clean energy transition, this transition to renewable energy. But there's a whole team, hundreds of people behind the scenes that are working to operate the plants and the system that exists today, and they're often forgot about. And so our system operators, our plant operators, our maintenance teams have really had to adapt to a lot of changes as the systems changed, our operations changed. We've invested in some modifications for some of those changes, but other changes involve procedures and practices that had to change and shift. And the people behind the scenes that make this happen are super dedicated. They are there for us 24 hours a day, 7 days a week. They're your friends, your neighbors, your family, and they're the people who keep the lights on.
Well, thank you for that, Mike. Thank you, everyone, for joining us for this session. I think up next is lunch for everyone. Thank you.
Thank you. Aloha.